So we will start the vertical circular motion. So we have introduced about the vertical circular motion in the last class. So today we will complete the session. So why this vertical circular motion comes under the work power energy chapter? Because in this vertical circular motion, the particle is moving against the gravity. Okay, so let us say the mass m is there, so it is moving against the gravity. Why? Because gravity is acting downward. So some amount of work is being done by the gravity itself. So that means I have to consider the work. That is not the case when the particle is moving in a horizontal circle. Let us say this is the horizontal circle and the particle is moving along this horizontal circle. So here the mg is acting vertical downward. So it is not on the plane itself. So that means there is no effect of mg on a horizontal circular motion, but the effect of mg is there in case of vertical circular motion. Okay. So that means they have to take care of that. Another important point regarding this circular motion is that so there are two possibilities. One is the mass is tied with a string and the mass is tied with a rod. So if the mass is tied with a rod, then tension in that rod can never be zero. Okay. But when the mass is tied with a string, then the tension can be equal to zero. Or the tension can be equal to zero at any point of time. Okay. So there are two situations, either the tension can be zero or tension cannot be. So now my question is that, first question is that, what is the minimum velocity at which the particle has to be projected? So the Q minimum number, so that it will perform a vertical circular motion. Okay. So you want to calculate the velocity at point A. Let us say the mass of the ball is n. So at point A, what is the velocity that has to be imparted on that particular ball so that it can complete the vertical circle? That means it will cross the point B, then cross the point C, then again come to D, then again A. Okay. So if the particle is moving in the upward direction, let us say in between A and B, I say there is one point, let us say this is the point. Okay, let us say is the A prime point. So A prime is the point which is between A and B. Let us say at this particular position, the angle made by the ball with the vertical is let us say theta. So for this situation, so here the T is acting in this direction. So component of mg is coming downward. And let us say at this point A prime, the velocity is v prime. Now corresponding to this, there is one component of mv square by r that should be equal to the centrifugal force, and then there is another component of mg that is equal to mg cos theta that will be along with that. So here between the particle whenever traveling from point A to B, can I write T should be equals to mv square by r plus mg cos theta?
Yes, sir.
That means what we ensure that this number can never be zero between point A to B. Okay, but what you can ensure that whatever be the value of tension that at point A prime, let us say this T prime number is T prime, that is less than the tension at point A. Why? Because as the particle is moving upward, so gradually the V value will be reduced. Initially the particle will be projected with the velocity of u. Once the particle reaches at point A prime, the velocity that I said V should be less than u. So since V is less than u, I can say clearly that as the particle is moving from A to B, tension is going to reduce. Okay, but it can never be zero. Now come to the situation when the particle is in between B and C. Let us say there is another point. If I say this is the B prime point, which is located in between B and C, and in that situation, let the particle is making an angle theta with the vertical again. So at this point, let us say this is the T number, this is the mg, and at this point, let us say the velocity is v again. So this is equals to mv square by r again. Now the t, so this component is theta. So t cos theta will become mg cos theta will be along the t direction. So can I write t plus mg cos theta should be equals to mv square by r? That means between these 2 points, t is equal to how much? mv square by r minus mg cos theta. So I can ensure that when the particle is moving from B to C, the tension inside the particle is going to be reduced. Okay, but here it is reducing, but it cannot be equal to zero. But in this situation, since the negative sign comes in between, so between B and C, the tension can be equal to zero. So as the particle is moving to point from B to C, gradually the tension is reducing. And at point C, the tension is minimum. PC is minimum. Nah. So since the particle is moving from B to C, so at between B and C, the tension is maximum at B. But at point C, it should be minimum. And can I say TC minimum should be equal to 0 to complete the vertical circle? Why? Because I have asked to calculate the minimum value of U. What is the minimum value of U? Which you have to throw it so that the particle will complete the vertical circle. If I say that at point C, the tension is equal to 0, corresponding to that, what is the velocity with which the particle moving at point C? That is V. So that means at this point, mg is acting downward and mv square by r is acting upward. Okay. So these two numbers will balance each other. That means that point C, at C, if I say T, C is minimum, and for minimum, this number, if I say it is 0, if I assume that at TC, tension is equal to 0, for that situation, can I write mv square by r should be equal to mv, or v square should be equal to r into mv. That is the velocity that is required at point C. That is the velocity at point C. Minimum velocity at point C, which is the particle has to be thrown at certain velocity A, so that the particle will complete the vertical circle. Okay, so that the particle will complete the vertical circle. So what you understand from this analysis is that once the particle is moving from A to B or B to C, gradually throughout this path, velocity is decreasing as well as tension is decreasing. Okay, but what we ensure that between A and B, T can never be 0. But there is a possibility that between B and C, T is 0. And if I assume that at point C, T becomes 0, that is the minimum value of tension. And if that is the condition, then what we can ensure that if I throw the particle with a velocity of u mid that we want to calculate, correspondingly velocity at point C should be equal to RNG or NGR. That is the condition. Now, if I allow the work energy theorem between point A and C, in the C point, and we found that velocity at point C is equals to v square equals to mg into r for T to be 0, because the particle is connected with an ideal string, and for ideal string, tension can be equals to. So once the particle reaches at point C, if I put the condition that T equals to 0, that will give the value of minimum velocity with which the particle has to be projected. Now we apply the work energy theorem between A and C. So what you write that work done by all the other forces. What are the forces are there? First force is the tension. Tension is one force, because at any instant I can see that one force is tension is acting there, another force is mv square by r, that is centrifugal force. So plus work done by centrifugal force, that should be equals to kinetic energy plus initial kinetic final potential energy minus kinetic energy initial plus initial potential energy. This is the work energy theorem. Total work done should be equal to change in energy. What is that energy? That is the mechanical energy. Now regarding the tension work and the work done by the mv square by r, that is centrifugal force, both of these two work will be 0. Why? Because the displacement is along this tangential direction ds. Corresponding this angle is 90 degree. This angle is also 90 degree. So both tension and mv square by r are the component of forces which are tangential to the direction of movement. That means both of these two work will give to 0. Okay. Why? Because theta becomes 90 degree. So you know that when the theta is 90 degree, then work done by that particular force becomes 0. So you are only left with the right hand part of the equation. So what you can write that final kinetic energy plus final potential energy should be equal to initial kinetic energy plus initial potential. So that means purely conservative force is still. So this is the equation of the conservation of energy, which is applicable only for the situation where the conservative forces are there. There are only one single conservative force is there, that is the gravity. Another force, that is spring, is not there. So we only consider the gravity. So for that, let us say I put this A point as our reference point of the reference line. So point A is lying on the reference line. So can I say initial potential is 0? And initial kinetic energy, I throw the particle with the velocity of u, so half m u square. That should be equal to final kinetic energy. Final kinetic energy is at point C. That is equal to half m vc square plus kinetic potential energy is point A and point C. The vertical displacement between these 2 points is 2r basically. Right? Point C, that a distance of 2r from point A. So can I write that is equal to mg into 2r? Okay. So this is the final energy equation. So if I multiply both sides by half, I am getting mu square equals to 4mgr plus mvc square. Now we know that vc square equals to mgr. So I write 4mgr plus another mgr. That should be equals to mu square. So cancelling m both sides. So we are left with u square equals to 5mgr. So that means that gives the value of u that should be less or equals to 5mgr. Sorry, less or equals to, no, greater than or equals to, that u value should be, that u number should be greater than or equals to root of 5gr, so that the particle can compute the vertical circulation. So this is the first condition that I am getting, that if I project u square is equal to 5g, right? Yes, not in. M is not there. Okay, 5gr. So m is already cancelled out from both sides, so root of 5gr. So this is the minimum velocity of projection of the particle in order to compute the vertical. Let us say I am doing one calculation. So let us say I am taking r equals to 1 meter, m equals to 1 kg, and I want to calculate what is the minimum value of projection. So u should be equals to root of 5 into g means 10 and r means 1. That is root 50. If I project the particle with root 50 meter per second, then only it will complete. If I project the same particle, let us say with the speed of root 60. So if I project with the u equals to root 60, then also it will complete. But for this situation, tension at point C is not equal to. Okay, that means I have to calculate the what is the minimum speed with which I have to throw the ball so that it will complete. So our answer is root of 5g. So if I project the ball with a minimum speed of root of 5gr or more than that, then only it will complete. If I throw the ball with a speed of exactly equals to root of 5gr, then only the tension at point C is equals to 0. Okay. Let us say I am doing this calculation. So you are asked to calculate the tension in the string when the body reaches that B. Now first of all, you have to check whether the body can reach up to point B or not. Okay. So I am projecting the ball with a 10 meter per second. So requirement of u to complete the vertical circuit, that means to reach P point, what is the requirement? U should be equals to root of 5gr. That means root of 50. Yeah, because r is 1 meter. And I am throwing the ball with a 10 meter per second. That means it is equals to root of 100. Now certainly root of 100 is greater than root of 50. That means it will complete the vertical circle. That means it is essentially going to cross the point B. Okay. So first you have to check whether the particle can cross the point B or not. So I am getting the situation that here in this situation the particle is crossing the point B. Now at that point you are asked to calculate the tension inside the string. So you have to draw the free body. Let us say at this point the particle is crossing the B point with the velocity v. So corresponding to that, I know that this is the mg square by r force, and this is the t force, and there is 1/4 mg is there. So if I say this angle is 37 degrees, so this is also 37 degrees. So mg cos 37 will come into this. So mg cos 37 means 4 mg by 5. Okay. So I am getting just t plus 4 mg by 5. That should be equals to mv square by r. So this is the first equation that I am getting. Now I have to calculate also the velocity at that particular point. So for that, I have to do the energy balance equation between point A and point B. And I know that in this type of situation, work done by the tension force, work done by tension force and work done by centrifugal force, both are going to be 0. So only thing is that I have left with kinetic energy and potential energy. So initial kinetic energy, initial Ki plus Qi should be equal to Ka plus Ea. Now what is Ki? Ki is half mv square. So simply write half m into v square means 10 square, because I am projecting with a 10 meter per second. Potential energy is 0. Final kinetic energy is equals to half m into v square. I want to calculate that v number and I have to write the potential energy. So for potential energy, again I have to calculate the vertical distance between point A and B. So this is the vertical distance. If I say this is r number, so that is r cos 37. R cos 37 number. Why? Because this is angle 37 degree. So r cos 37 is this distance. Okay. Plus r. So total h is basically mg into h. And what is h? H is r plus r cos 37. So cos 37 is 4 r by 5. So that means 9r by 5. That means mg r plus 4r by 5 means 9r by 5. So 9r by 5 is that number. And here it is 100, 10 square means 100 by 2 means 50m. So 50m equals to half m v square plus this number. So cancel all the same and multiply by 2. So I am getting 100 equals to v square plus 2g into 9r by 5. Now r is 1. So 2g means 20 into 9 means 180. 180 by 5. So means 36. So v square plus 2 into 10 into 9 into 1 by 5. So 5 into 10 means 2. 2 into 4. 4 into 9 means 36. So v square plus 36 equals to 100. So v square becomes 100 minus 36. That means 64. So v becomes 8 meter per second. Okay, once the particle reaches that point B, the velocity around 8 meter per second. So now we put this 8 meter per second value in the equation number 1. So once I put in equation number 1, so I can get the value of t. So t should be equal to t plus 4m. m is given as 1 k. So 1 into g means 10 by 5. Okay, that should be equal to 1 into v square means 64 by 5 by 1. By 64 by 1 in v square by r. Okay, so here I am getting 8. 5 into 2 is 8. T plus 8 equals to 64. That means T equals to 56 Newton. So that will be your answer. So tension at point B equals to 56 Newton. Okay. So whenever you are asked to calculate tension or velocity, first of all check whether the particle can reach up to that point or not. So once I ensure that the particle can reach up to point B, then only I can do the calculation. Okay. Now, so we know that for a vertical circular motion, if I project a particle with a value of root of 5 gr, then I understand that the particle can cross this point C. C point. Okay. Now I want to calculate what is the minimum velocity of projection so that particle can go up to this point, that is the B point. Okay. So that means certainly this number should be a number which is less than the root of 5 gr number, because now I am going to go up to point B. Up to point B. So if I want to go up to point B, so what happens at point B? Let us see. So that means beyond point B, the particle is not moving up. Okay, beyond point B, the particle is not moving upward. That means only here the velocity has to be there. If velocity is there at point B, then the particle cross point B. I want to throw the particle from A in such a way so that it cannot cross the point B. Just touching the point B, and after that again comes back. Okay. So coming back means it will cross the point A again in the downward motion, and on the other side it will reach another point B time over there. So that means this is a kind of pendulum motion. It will oscillate like this. That's why the statement of the problem is you are asked to calculate the minimum velocity for the particle to perform a pendulum motion. That means the condition for this that at point B your velocity should be 0. Now if I simply apply the work done between point A and B, knowing that the work done by tension and work done by centrifugal force both are equal to 0. Both are equal to 0 because these two forces are perpendicular to the direction of displacement. So we are left with only initial potential energy plus initial kinetic energy should be equal to final kinetic energy plus final potential energy. Now taking again the same reference line as point A, so I can say initial potential energy is 0, kinetic energy is equal to half m into u square. Okay, and that should be equal to final kinetic energy. Final kinetic energy has to be 0 because I am saying the velocity at point B is 0 and potential energy equals to vertical distance, and that vertical distance is simply r. So this number is r. Okay, so particle at the distance of r from point A, so that is equal to mgr. So mm comes out, so u should be greater than or less than root of 2 gr. Okay, not greater than. If it is greater than, then we will cross. It should be less than or equal to 2. Less than or equal to 2. So if I project the particle with a velocity either equals to 2 gr or less than 2 gr, then the particle will go up to the B point. Let us say again, if I say r equals to 1 meter, that means if I project the value with the root 20 velocity, then the particle will go up to point B. up to point B, it will go. If I project the particle to 15 meter per second, then it can go up to this point, let us say this point, let us say B1 point. So it will go from A to B1 in this direction, then again coming from B to A, and on the other side it will place the same point, that will be B1 again. Okay, so it will be symmetrical that. So in this way, the particle can perform a pendulum type of motion, and for this situation, u must be less or equal to root 2g. Less or equal to root 2g. Why? Because if you project the particle with a more than velocity of 2g, root 2g, then the particle will cross the point. But I don't want to cross the point B, so that means I have to throw the ball with a speed which is between root 2g, less than root 2g. Okay, less than root 2g. So now in here you are asked to calculate to find the maximum possible angle. So here again the minimum value, so in order to reach the particle up to point C, the velocity at point A should be equal to root of 5gr. I know that. So that is root of 50. Our answer is 2 given. So that means because root of 4. Okay. So that means it cannot go up to point C. Now in order to go to up to point, let us say B prime, the velocity at point A should be equal to root of 2gr, that means root of 20. Again our speed is less than, so root 20 is more than root 4. That means what I can say, the particle will not cross the point B prime also. Okay, so in between B and A, there is another point B prime and A. One point is B. Up to that point, the particle will. So first of all, you have to check up to which height the particle can go. Now, that is, it should be certainly less than 90-degree angle. So you are asked to calculate the theta. So since it is going up to point B, so what we say that at point B, velocity must be equal to. Now we apply the work energy conservation between A and B. So initially, what you write, A initial plus U initial should be equal to K final plus U final. Now what is K initial? That is initial kinetic energy, that is equal to half m into U square. So half m into 2 square means 4 plus potential energy is 0 and kinetic energy is 2 is 0. Now what is the final potential energy? So final potential energy comes due to this vertical height difference, is this height. Now what is this number? So that number can be taken as, if I say this is R number, so this value is how much? This is R cos theta. Now this is R cos theta. So total distance is R minus R cos theta. So that should be equal to mgr into 1 minus cos theta. Okay. So total distance from point A to O is R, and the projection of OB is R cos theta. So R minus R cos theta will be the vertical height H. Okay. So that is the answer. So ultimately A cancels out. So 4 should be equal to 2gr into 1 minus cos theta. Now put the value. R is given as 1. It is 20 into 1 minus cos theta. That is 1 minus cos theta should be equal to 4 by 20, means 1 by 5. So cos theta should be equal to 1 minus 1 by 5, means 4 by 5. That means theta is equal to 37 degree. Okay. So we calculate that up to 37 degree angle the particle can move. Why? Because at 37 degree angle, it will reach the point B where the velocity becomes 0. That means it cannot move further. Okay, it cannot move further. Okay. Now the condition is that, so we know two different conditions. One is root 5gr. So if I project the particle with root 5gr, so it will go up to this. If you throw the particle with root 2gr, it will go up to that. Now, what happens if I project the particle in between these two numbers? So if I project the particle with this in between two numbers, then essentially it will go up to a certain point which is in between these two numbers. Okay. So if I say this is a point A, so if I project the particle with root 5gr velocity, then it will go up to point C. If I project the particle with root 2gr velocity, then it will go point B. So in between there is another point D. Up to that the particle will go. Now what happens at point D? At point D, tension becomes 0. Tension will be equal to B is not equal to. Because of tension to be 0, that means the tension 0 means the stream will now slack. So beyond that point, the particle will perform a projectile. Okay, this is called the projectile motion. Why? Because at point D, tension becomes 0. So because of the theta angle, now the particle is, so if I say at this point the particle is projected with the velocity v tangential to this direction. So if that angle is theta, then this angle is also theta. This angle is theta. When at an angle theta, the particle is projected, so it will perform projectile motion like this way, and ultimately it will touch the circle at somewhat distance. Okay, once it will touch this point, then the string becomes tight again. Up to starting from D to let us say E point, inside this point the particle is performing the projectile movement, and between this point there is no tension inside the string. T is equal to 0. An entire path will be a parabolic path. We already studied this parabolic path. So the only thing is that you have to apply this. Now another important point is that once the particle reaches at point E, now the tension inside the string becomes non-zero. Now here the P is non-zero. Now from point E, again it will go in this direction and continue on. So from E, it will go up to A, then B, then D, then again projectile. Like this way, there will be a periodic motion like. So particle will go from this point to this point. Okay, like this way, it will go, and then again we go the projectile path. So like this way, the particle is repeating the path. So this is what happens if I throw the ball with a velocity which is lying in between root 2gr to root 5. So in this type of question, you are asked to calculate that angle theta from where the particle will perform the projectile. Let us say it will perform the projectile movement at point D. So the condition to find the theta is that at point D, you have to make the tension to be 0. So at point D, if I do the force equation, so this is the mv square by r value, and this is the mg number. So this is the T number. So T plus mg cos theta, that should be equal to mv square by r. So at D, what you can write, T plus mg cos theta, that should be equal to mv square by r. Now since T is 0, so what I am left with? I am left with v square equals to rg cos theta. So this is the velocity that is achieved by the particle at point D before starting the projectile movement. So now if we apply the work energy theorem between point A and D, so can I write kinetic energy plus potential energy initial should be equal to final kinetic energy plus final potential energy. Initial kinetic energy how much? Half mv square. Initial potential energy how much? 0. Final kinetic energy is half mv square. Now what is v square? V square is rg cos theta. Simply write this number rg cos theta. And potential energy. So potential energy means this height plus that height. So this is r. This is r number. And what about this height? This is r cos theta. So I am writing mg into r into 1 plus cos theta. So now again multiply by 2 and cancel the n number. So I am left with u square equals to 2gr cos theta plus 2gr, not 2gr, simply gr cos theta, because I am multiplying by 2. So gr cos theta plus 2 times of gr into 1 plus cos theta. Okay, 2 times of gr into 1 plus cos theta. So I am left with 3gr cos theta plus 2g. So from that, can I write cos theta number should be equal to u square minus 2gr by 3g. Okay, so this is the point from where the particle will perform the projectile. So very, very important relation. So you can apply directly for these sort of problems where you ensure that the particle is between B and C, that is at point D. So it all depends on the projection velocity. What velocity you are projecting the particle, depending on that, you can check up to what point the particle will be. Whether it is crossing the point B only, or whether it is crossing the C, or whether it is crossing the D. Like this way, you can calculate at what point the particle will reach. And if the particle is being projected between these two numbers, 2gr to 5gr, in between root 2gr to root 5gr, the particle will eventually perform a parabolic motion or the projectile motion. So the point from where it will start the projectile, so for that theta is this one. Mind it that theta is calculated from the vertical direction. So that angle is from the vertical point. So this is the answer for this equation. Okay, let us do one calculation. So now the particle is projected with a velocity of root 40. So I know that in order to reach this point, the velocity should be root 50. In order to reach this point, the velocity should be equal to root 20. So root 44 is lying in between root 20 and root 50. So surely the point will be at point B, which is in between these 2 points. Now you are asked to calculate the maximum height. So for that you have to calculate the cos theta number. So cos theta should be equal to u square minus 2gr divided by 3. This is the formula. So what is u square? U square is 44 minus 2g, r is 1, so 20 by 30. So 24 by 30. So 24 by 30 means 6 by not 12 by 15 and 3 means 4 by 5. 4 by 5. So cos theta becomes 4 by 5. That means theta is equal to how much? 37 degree. So the particle will reach a point B where theta becomes vertical angle is 37 degree. Now you are asked to calculate the maximum height. So what is the maximum height? This is the one height, that is r cos 37. And there is another height, that is r. Okay. So total height attained by the particle from the ground should be equal to r into 1 plus cos 37. Cos 37 is 4 by 5, so it becomes 9r by 5. So this is the height attained by the particle once it is being projected with a velocity of root 44 meter per second. It will go up to point B. Understood?
Yes, sir.
Any doubt?
No, sir.
So in this situation, there is no string. Okay. So earlier case, the particle is performing vertical circle using a string. So when we tied the mass with the string, then the particle is performing a circular motion. Now, inside a loop, let us say this is the loop. So inside a loop, I am projecting one particle of mass n with a velocity of u, so that I want to calculate what is the minimum velocity of projection so that the particle complete the vertical circle. Okay. So here there is no tension, but only thing is that here the normal is supporting the particle. No? So once the particle, so I want to calculate check whether the particle can reach the topmost point or not. So once the particle is reaching at the topmost point, let us say the particle is moving with a velocity v, corresponding to that. So this is the mv square by r number, and this is the mg, and another normal is there. Okay. So at this point C point, if I project the particle point A, so with the same analogy, I will make the normal at point C over here is G, not the tension, because it is not tied with the string. So if I make normal to be 0, then what is getting? So mv square by r, that number should be equal to mg. So same expression that I am getting, that is v square equals to rg. So this is the velocity of particle once it reaches at point C. So again, if I do the energy equation balance from between A and C, I will get the same equation of root 5 gr. Okay. So what is the energy? So kinetic energy at point A plus potential energy at point A should be equal to kinetic energy at point B plus potential energy at point B. Here instead of normal, here instead of tension, the normal is coming. But at any instant, if you check it, normal is in this direction, like the tension, and mv square by r is in this direction. Okay. So both are perpendicular to the real vector. That means both of these two will be the 0 1. So only we are left with the conservative force, so only the kinetic and potential. So half m u square is the initial kinetic energy, potential is 0. That should be equal to half m v square, and v square equals to rg. Okay. Plus kinetic initial potential at point B means mg into 2r. Because B is the distance of 2r from point A. So this height is 2r. Okay. So if I multiply by 2 both sides, so ultimately I am getting u square equals to 2gr, not 2gr, 4gr plus gr. That means u square is equal to 5gr. That means u minimum at which it has to be projected, that is equals to root of 5gr. And the same answer that I am getting once the particle is tied with the string and it is allowed to go for the rotation. Okay. So either I can go with the string, answer is same, or I can go inside a loop. If the particle is projected inside a loop, then I am getting the same answer. Again, the same condition. If it is root 2gr, then we go up to this point. Between root 2gr to root 5gr, then we go up to that particular point. So all the analysis that I have already did for the string equations or the string problem, the same situation can be done over here also when the particle is projected inside the loop. Okay, with a velocity in medium. Okay, now come to the second category of problem where I am keeping the rod. Now, as I have already mentioned that for the rod, the restriction is that inside that rod, the tension at point C cannot be equal to 0. Cannot be equal to 0 because rod is a rigid element. So it cannot be give a tension to be equal to 0. And I am assuming that mass of the rod is negative. So there is no mass of the rod, only the mass of the ball is there. So potential energy is not gained by the rod. Only the ball will gain the potential. So at point C, tension can never be 0. So what if put the assumption that at point C, now the velocity becomes at point C, velocity becomes 0. So that will give the condition for the minimum velocity at which the particle is projected. So we are simply do the energy equation, write the energy equation so that I can apply this between point A and C again. Okay. So I am writing kinetic energy point A plus potential energy at point A should be equals to kinetic energy at point C plus potential energy at point C. Now potential energy at point A is 0. Kinetic energy is equals to half mv square, and that should be equals to kinetic energy at point C is 0 plus mg into 2r. Okay, so ultimately u should be equals to 4gr. Okay, so this is the minimum velocity root 4gr at which it has to be projected so that it will cross the C point. So earlier situation when the raw mass is tied with a string, I have to apply more amount of velocity. So root 5gr is the more number corresponding to the situation when the same mass is tied with a rod. Okay, so this is the answer for this. Now consider the situation. The ball is pitched in between two concentric loops. So these are the two different loops. So two loop system is there, and in between a ball is there. Now you are asked to calculate the minimum velocity which it has to be projected so that it will again complete the vertical circle. So that it will complete the vertical circle. So there is a circular pipe. You can say it is a circular pipe. So in between the angular portion, you are projecting the ball so that the particle will complete a vertical circle. Now what is happening over here? Here the tension will be not there. Again, and know that normal is there. Okay, normal is there. So once the particle, so if I say forget about the inner loop, first consider the outer loop. So this outer loop. So for outer loop is the same question that we have already solved. Now, so if I project a particle with a certain velocity, I know that at a certain instant, if the velocity is not sufficiently high, the velocity becomes 0. So instead of reaching at point, let us say this is the point A, and this is the point B, and this is the point C. Okay, so I know that if I project the particle, just recall about the situation when the particle is tied with the string. So if I tied the particle with the string, and if I project the particle with a velocity of between root 2gr to root 5gr, then I know that at some point the particle will lose the contact or become the tension equals to 0. Now, remember the fact. So here the tension becomes 0. But so consider the outer loop. At this point, what happens? The outer loop will be detached. Okay. So normal by the outer loop becomes 0. Normal provided that the outer loop will be 0. But at this point, the inner loop will be the subject. So part will not fall. So now the inner loop will give the normal. So inner loop will come into the picture. So from, let us say this is a theta angle at which the inner loop is active. So similarly, diametrically opposite, there is another theta angle up to which the inner loop will be active. So particle is supported by the inner loop from this point to this point. This point to this point, the particle is supported by the inner loop, and rest of the particle is supported by the outer loop. So from starting from this point to the other point, the particle is supported by the outer. So that's why there are two loops are there. That's why there are two loops. So now again you are asked to calculate what is the minimum velocity so that particle can complete the vertical cycle. Now what we do that the particle will complete the vertical cycle until now the minimum condition the particle should reach over here where the velocity becomes 0. Okay. So what is the idea of putting two different loops? So one loop is providing the support for some part of the time, and another loop is providing support for another part of the time. Okay, so in this situation, what is happening? In this situation, again, I am getting the same result. That means if I put V equals to 0, and if you do the same energy balance, I will get the same answer as root of 4GR. Okay, so particle may be trapped in between two circular pipe. Okay, or particle may be only supported by one particular loop, one inner loop. So once the only one single loop is there, then the answer is root 5G. But once the two loops are there, or the two the strap between a circular pipe, then the answer is root 4G. That is exactly similar to the situation when the rod is active. Okay, so this property is analogous to the situation when the rod mass is tied with the rod. Okay, so for that I know in order to complete the vertical circuit, U should be equal to root of 4GR. The same answer can be applied over here. But once we do this type of situation, only one single loop is there, that is the outer loop. So that is nothing but the situation when the ball is tied with a string. So the string. So for that we know the minimum velocity U should be the root of 5GR. Okay. So these are the two different situations, but these two situations can be dealt with the string concept as well as the rod concept. Okay, string concept and the rod concept. So this is the situation. Let us say, so you are asked to calculate find out the region where the particle is supported by the outer ring and where it is supported by the inner ring. So for support of the outer ring, so there must be one point up to which the particle will go. Let us say this is the theta position. At this point, let us say the outer ring normal becomes 0. That means that at this point tension is equal to 0. So for the outer ring, apply the concept of the string, and for the inner ring, apply the concept of the, when both the rings are there, apply the concept of the rod. So you are projected with a velocity of root 44. That means it is less than root 50 and greater than root 20. Greater than root 20. So that means the particle will go up to that particular point. Let us say I am giving the naming. This is the point A, this is the point B. So vertically opposite there is another point B. So this is the supported by the outer ring. This part is supported by the outer ring. Okay, because the particle is projected with a velocity in between 2GR to 5GR. So there is a theta angle, and I know how to calculate the theta angle. The formula is already known to me. So cos theta is how much? Cos theta is equals to U square minus 2GR divided by 3GR. Okay, U square is 44, 2GR is 20 by 30, that means 24 by 30. Okay, so 4 by 5. So cos theta becomes 4 by 5, that means theta is equal to 37 degree. So up to the angle 37 degree, the particle is supported by the outer ring, and then the inner ring will be active. So inner ring will take care about this part. So total distance region which is supported by the inner ring is 37 plus 37, that is 74 degree. Okay, so find out the region where the particle is supported by the outer ring. Outer ring is basically for 360 degree minus 74 degree. This part is supported by the outer ring, and inner ring is supporting the 74 degree angle. So these are the two answers. So one is basically the up to the angle which is 74 degree supported by the inner ring, and outer ring is supported rest of the portion where there is a hemisphere. So this is the hemisphere. Okay, now there is a particle of mass m is there. We apply a certain jerk at this point. Jerk means some kind of impact. You are hitting the block with a stick, let us say. So that means you are providing a jerk. So you are asked to calculate the angle at which the particle lose the contact. So losing the contact means the normal at this point should be equal to. Okay, you start the particle with some velocity. Okay, so particle moving down, 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 down. So at this point, let us say I am taking the situation that the particle lose the contact. So what is happening over here? Here the normal is acting in this direction. So this is the direction of the normal force. mg is acting vertically downward. So let us say the particle is moving with the velocity v over here. So corresponding to that, one force is mv square by r acting outward. Okay. The component of mg cos theta is along this direction. Okay, so mg cos theta is there. So I can write the equation for the normal. So n plus mv square by r, that number should be equal to mg cos theta. Okay. Now in order to make contact to be loose, so n number must be equal to 0. So if I put n number equal to 0, so I am getting v square equal to rg cos theta. So this is the required speed at point of losing the contact. So now if I apply the energy conservation between point A and let us say this is the B point by drawing a line which is passing through the let us say B point. So if I say this is our reference. Okay. So I took one reference line. So whenever you apply the energy conservation equation, try to draw the reference line. So based on that reference line, again you can write the energies. So here also only the work is being done by the gravity. Okay, because normal is perpendicular to the situation. So normal is not doing any kind of work. So I can write initial kinetic energy plus initial potential energy at A point should be equals to UV plus KB. Okay. Now, since I am providing a small amount of jerk, what we ensure that it will give certain velocity and which is almost equal to 0. We assume that the velocity at point A is almost negligible, so kinetic energy is assumed to be 0. So potentiality that is also equal to 0. That not 0 because it is at a certain height. So this height is how much? R minus R cos theta. So this is not equal to 0. This is so potential energy is equals to how much? mgr into 1 minus cos theta. Why? Because this number is r. I want to calculate this value. So total distance from this point to this point is r, and this distance is how much? This distance is r times cos theta. So r minus r cos theta, that is the value of potential energy, and that should be equal to potential energy at point B. So point B is lying on the reference line, so U at B will be 0, and kinetic energy equals to half mv square. Okay, half mv square. So if I put the value of v square equals to rg cos theta over here, I'm cancelling the m term, so 2gr into 1 minus cos theta, that should be equal to v square, means rg cos theta. So this gr cos theta with the negative sign comes over that side, so ultimately I'm getting 3gr cos theta. That should be equal to 2gr. So cos theta becomes 2 by 3. So that means this angle becomes constant. Yeah, this angle becomes constant. It does not depend on the radius. So if you take a very small sphere or very large sphere, the point of this contact will be always cos theta equals to 2 by 3. Theta has to be measured from the vertical point. So at this point, the particle will lose the contact from the hemisphere, and that does not depend on the geometry of the sphere. Now, after losing the contact, what happens? Again, the particle will perform the projectile. Why? Because at point B, the velocity is tangential to the path. So that means it will form a projectile path and ultimately reach the ground over here. Okay. So if I calculate if I deeply think about the point B, so let us say this is the B point from where the particle will perform the projectile motion. So this is the angle theta and this is the B point. At B point, the velocity is perpendicular to this line. So this angle is 90 degrees. Okay, so this is the B component. So now, this is the height dropped by the particle. So what is this h? So this h is equals to how much? This h is basically r cos theta number. So since I have known the value of theta cos theta, so h is known to us. So this angle is theta. So this is theta. This is 90 minus theta. This is theta then. Okay. So this is theta angle means 90 minus theta. This is theta. This is 90 minus theta. That means that is theta. So v has two components. Along x-axis is v cos theta, and along y-axis is v sin theta. V sin theta. Now, first of all, I have to take care about the time of fall. So, for time to calculate, so I apply the formula h equals to ut plus dt along the y direction. Okay. So, h is how much? H is equal to our r cos theta. R cos theta. What is u? U is equal to v sin theta into t plus half gt square. So, solving this equation, you can get the value of t. So, it is a quadratic in t, so you can get the information of the t. So, once you know the time of fall, now you can calculate where the particle will land. So, particle will do a projectile movement and ultimately will land over here. So this distance is basically the range of the projectile. So r is how much? R is equals to simply v cos theta into t. That number you can calculate. So once you calculate this number, that means you are calculating this number from this point. From this point, this distance is basically r. So in most of the situation, you are asked to calculate the location of the particle measured from point 2. So what is that distance? That distance will be equal to this r prime. Let us say this is r prime number because r is the radius given. So r prime plus this base length. So what is this base length? This is r cos theta, r sin theta. So r sin theta plus r double prime, that will be the total distance at which the particle will fall from the point of projection or from the point O or the center of the sphere. Okay. So in this type of situation, concept of vertical motion along with the projectile motion has to be applied. Okay. So come to this situation. So here there is a particle of mass m tied in a vertical plane to a thread of length m. So thread means string. If the particle is given a velocity of root 6 gl, so from this number I ensured that this number is greater than root of 5 gl. That means the particle is going to complete the vertical circle. So you are asked to calculate the tension in the string at the topmost point. Now since the value is greater than root of 5 gl, tension at point C is not equal to 0. Okay. So here let us say the particle is moving with a velocity v. Corresponding to that, this is the mg value. Corresponding to that, the tension will be acting downward. And here the particle has a mv square by r. Okay. So here capital T plus mg should be equal to mv square by r. Okay. So from this relation I want to calculate the tension value. But for that I should know the velocity v at that particular point. So for that I have to apply the work energy conservation between point A and point C, where the particle is moving v. Again assuming that this is the reference line, I am directly writing the potential energy at point A is 0. Kinetic energy is equal to half m into u square means 6gl. That should be equal to potential energy at C point equals to mg into 2r means 2l. Okay. Plus half mv square. Okay. So again cancel m, multiply both sides by 2. So I am getting 6gl should be equals to 4gl plus v square. So v square equals to how much? 2gl. Once I get the value of v square, put it over there. So this is v square by l. So v square by l is 2g. So here I am getting 2mg and plus mg plus t. So the t value should be equals to mg. So this is the tension at point C. So tension will be equals to mg. That is not equal to 0. Why? Because I am projecting the particle with a velocity which is more than root of 5g. If the projection velocity is more than 5gl, then the particle should have some kind of tension at point C. That's why I am getting the answer C equals to mg. Okay. Now the system is released from the horizontal position. So there is a mass m connected with the thread. Okay. No, massless rod. So it is the rod. Okay. It is the rod. So now you are released from horizontal position. You are asked to calculate the velocity of the particle and the tension in the massless rod at the bottom of position. So at this point the particle come down, and once it crossing this point, so you are asked to calculate the velocity and the tension inside. So let us say this is T. So in this situation mg is acting downward, and due to v there is another mv square by r, mv square by l. So tension at the bottommost position should be equal to mg plus mv square by l. Okay. Now again I have to calculate the v number. So in order to calculate the v number, I have to apply the work energy theorem between these 2 points. Let us say this is the point A, this is the point B. I am taking the reference at point B. This is the reference line. So kinetic energy at point A. So it is released. So since the particle is released at point A, so kinetic energy is 0. So potential energy is equal to simply mg into L. Why? Because this side is L. So that should be equal to kinetic energy at point B, that is half mv square plus potential energy, that is 0. So ultimately I am getting v square equals to 2gl. So put it over here. So v square by l is 2g. So mg plus 2mg. That means 3mg. So 3mg will be the tension, and v should be equals to how much? Root 2gl. So these are the two answers. So root 2gl and 3mg. So once the particle reaches at the bottommost position, then the tension is equals to root 2gl and Tension equal to 3 mg and velocity is equal to root 2 gl. Got it?
Yes, sir.
So moving on to the next situation, here there are two masses. There are two masses of each of mass m. So there are 2 point masses are connected by the light rod of length 2l. So each of length l and l, and it is t to rotate in a vertical. So they are rotating in this vertical plane with the angular velocity of let us say omega. Okay. So calculate the minimum horizontal velocity that should be given to the bottom mass so that it completes the circular motion in the vertical. So if it is only one single mass, then I know the answer is root of 4gl or 4gl. Okay, but here there are two masses are there. So if I project the particle, lower particle with a velocity u, so what is the velocity of this particle? I want to calculate this u naught number. So both are moving the same omega. Just say once I throw this, both are moving the same omega. Let us say the A particle is the B particle. Can I say omega for A particle should be equal to omega for B particle? What is omega? Omega equals to u by 2l. It becomes to u by l, u naught by l. So ultimately l cancels out. So u naught should be equal to u by. So this is the relation that I am getting regarding the velocity of each part. So if I throw the A particle with the velocity u, the B particle should have a velocity of u by. Why? Because they are moving the same combined speed. Under the same logic, you are asked to calculate the minimum component of velocity. That means at once the particle which is at the topmost position, so that means this velocity equals to 0 and that velocity is also becomes 0. Okay, so this is the minimum condition. So only thing is that both are having the potential energy, not the kinetic energy. Now simply I have to write the work done equivalent. Again, if I say this is a reference position, so initial kinetic energy is how much? Let us see Ki. First calculate the Ki number. That should be equal to how much? Half m into u square plus half m into u by 2 whole square. Okay. So if I take a mu square by 2 common, that should be 1 plus 1 by 4 means 5 by 4. So 5 by 8 a mu square. That is the initial kinetic energy. Okay. Initial potential energy Uy. Uy will be 0 for the A particle because A particle is lying on the reference line, but B is not lying on the reference line. So B particle is at a distance of L from the reference line. So it has a potential energy of mg into L. Okay, so these are the two components of the energy initially. Similarly, I calculate the final kinetic energy. So entire final kinetic energy is 0. Why? Because both the particles are at rest. So what about the U final? So for U final, so mg into for this first particle. So this particle is at a distance of 2l plus 2l means 4l above. 4l plus second particle is at a distance of this is l plus 2l means 3l from the reference line. So it is 7 mgl. Okay, 7 mgl. So final kinetic potential energy equals 2. Okay, now write the work energy thing. So initial kinetic energy 5 by 8 mu square plus potential energy is mgl. That should be equal to final potential, that is 7 mgl. Okay, that means 5 by 8 mu square equals to 6 mgl. So mm cancels out, so I am left with u square should be equal to 48 gl. 48 gl by 5. So u should be equal to how much then? Root of 48 gl by 5. That will be the answer. Option number 5. Okay. So you have to be very careful regarding the writing the energy equation. So in order to write the energy equation properly, you have to take care about different masses that may be there. Corresponding velocities, you have to take care about that. And also the potential energy. And in all these vertical circular motion problem, so work done by tension and work done by centrifugal force are always equals to 0. So you don't have to bother about that. Simply write the potential and the time. Okay. Now come to the second situation. So here you are asked to calculate or prove that there is a car moving over a convex bridge is lighter than the same car resting on the same. So prove that a car moving over a convex bridge is feeling lighter then the same car resting on the same V. So that means once the particle is moving with a velocity, that means it is the case number 1. And when it is resting, that is V equals to 0. So let us say it is case number 2. So this lighter, feeling lighter means you have to check about the normal. Okay. So once the particle is moving with some velocity V, let us say correspondingly the center of radius of curvature is R. So can I say here the mg is acting downward, and md square by r force is over there, md square by r in this direction, and corresponding with the n number. Okay, n number. So md square by r plus n should be equals to mg cos theta term. Now, md square by r plus n should be equals to mg cos theta, because component of mg has to be there. So from that one we can write the n number for the case number 1 should be equals to mg cos theta minus md square by r. This quantity. Okay. Now come to the second situation. So here what happens? The car is not moving. So not moving means now the centrifugal force, that is mv square by r, this force is 0. So only mg component is there and the normal is there. So normal is in the second situation is only mg cos theta number. Okay, mg cos theta number. Now can I say this number is less than the mg cos theta? No, this is n1 is mg cos theta minus something, and n2 is simply mg cos theta. So I can clearly say that n for the first situation is less than that of the n for the second situation. Hence, so the car number 1, which is moving, feeling lighter. Why lighter? Because n is less. Then the same car resting on the same beat. Okay, because in the second situation, when the car is at rest condition, that means there is no centrifugal force acting on the body, and under that situation, n2 will be equals to 0. Not n2 will be 0, mv square by r will be 0, and because of that, n1 is always less than n2 number. Okay. So again, the same opposite situation. If that the car moving over a concave bridge is heavier. Okay, why heavier? Because here the mg is acting downward again. Normal is in this direction. Normal is in one direction. And regarding this v, so I have to take mv square by r in this direction. Okay. If I take this angle is theta, so n should be equals to, in this first situation, n should be equals to mg cos theta plus mv square by this quantity. Okay. And when the car is at rest condition, so v is 0, that means no mv square by r force, only mg is there, and it is supported by the normal in this direction. So it is balanced by the mg cos theta. So can I say n2, second situation is equals to mg cos theta. So now I am saying that n for the first situation is greater than the n for second situation. So when you are resting on a concave bridge, you are feeling heavier. When you are resting on a convex bridge, you are feeling lighter. Okay. So depending on the radius of curvature, the n number is going to be changed. Okay, n number is going to be changed, and accordingly you can answer this. Okay. So this is the same problem that we have already discussed. So it is released from the top of a smooth fixed hemisphere action. So I already know that at this angle theta, which is equals to cos theta equals to 2 by 3, the particle will be detached. Okay. At cos theta equals to 2 by 3, particle will be detached. So the angle with the vertical where the lose contact. The velocity at that instant it flies up. So at this point you are asked to calculate the V number. Now what is the V that we have got? That is equals to Rg cos theta. This is the answer that we got, root of Rg cos theta. So R is given as R, G is T. So it is Rg, and the cos theta is 2 by 3. That means 2 Rg by 3. Root of 2 Rg by 3. So cos theta is 2 by 3, velocity is root 2 gr by 3. What is about the height where it flies up? This height number. This h. H is how much? R cos theta. So h equals to R cos theta. That means 2 to R by 3. So that means option number B is the correct one. Okay. So this type of problem. So mind it that at this point u is equals to 0. We are taking that u is equals to 0. Okay. If there is certain value of u, If there is a certain value of u is given, then that will come inside the energy equation. And if that is there, it will fly at an angle alpha, which is less than theta. Okay, so less than theta. So if the value of u is given, I'm writing over here, if u is given, u is not equal to 0 at initial position, then we will fly at an angle alpha from the vertical, which is less than theta. Okay, which is always less than theta angle. Okay, so now there is a small block in short into each of the four tracks. There are four different tracks that have been shown to you. Each of the track rises to the same height. That means these heights are same for each and every track. Okay, let us say this is h. For each and every track, this is h. Okay. So the speed with which the block must enter the track is same in all cases. Let us say the particle is entering with the speed of u in all cases. The highest point of the track, the normal reaction maximum. Okay. What is the point? What is the option in which situation you are asked to calculate the point at the highest point of the track, the normal reaction is maximum in which case? The normal reaction at the highest point. Normal reaction, that means let us see this point. At this point. Okay. So all are having the same height. All are having the same height. So if I project the particle with a velocity of u at this point, now let us say here the particle is v. Velocity is v. Okay, velocity is v at this point. Velocity at this point is v, so I can calculate the velocity at point v. So provided I do the energy between these 2 points. So simply the kinetic energy over here is how much? Half mu square. Potential is 0. So half mu square equal to 0 should be equal to half mv square plus mg into h. Because for each and every track, height is equal to u. So if I calculate the v square number, so I am getting u square equals to v square plus 2gh. That means v square should be equal to u square minus 2d. So that number is same for each and every track. That number is same for each and every track. Now, at highest point, the velocity remains same for each and every track. But you are asked to calculate the normal about this. Normal about this. So corresponding to this, so since v is constant, so if I draw the free body diagram at any point, let us say for this diagram, so here the mg is acting downward, normal is acting downward, and it is balanced by the mv square by r. R is the radius of curvature at that highest point. Okay, radius of curvature at this point. So the equation for normal is equal to how much? Mv square by r minus mg. Okay. So n will be maximum. N will be maximum where this r number will be minimum. No. Because v is same for each and every situation. V is same for each and every situation. So if the first term that mv square by r is maximum, then only it will be maximum because subtraction from mg is constant. So n will be maximum for the situation where r will be minimum. What is r? R is nothing but the radius of curvature. Yeah, radius of curvature. So radius of curvature should be small. Smaller number means if you feel the track, so can you feel that at points, this point, if I draw a circle, this is the circle. At point B, the circle will be somewhat larger. At point B, the circle will be more larger. At point B, the circle will be more larger. Why? Because the flat is increasing. Okay. So as the radius of curvature is maximum, small at point A, so option will be point A. So you have to judge by seeing the figure. When I see the figure, I found that R, that is the radius of curvature, is minimum for the diagram A. So if R is minimum, so that the mv square by R number is maximum. Okay, that is normal is going to be maximum. Why? Because mg has no effect. Why? Mg is a constant term. That is always on the negative side. Okay, so if I calculate the mv square by R number, if it comes to be the lower side, minimum side, that is for that situation, n will be minimum. Okay, and by this figure, if I comment, so on the figure D, not figure D, because D has more bending compared to A, B. Nah. So between compared to B and D, B has the largest circle. So normal will be minimum at point B for the is okay normal, and here normal will be maximum. Understood? So
Okay.
this is how you have to attack this type of problem, where you have to define in which what is the proper car. What is the proper car? Okay. So finally, there is another type of question where the spring comes into the picture. Okay. So let us say there is a bead which is held at a point B at rest. Okay, at natural length. So natural length of spring is given as 7 meters. Now all the information is given to you. So first calculate what is the length of the spring on the initial at point B. So if this is 7, then this is also 5. No? So 7 plus 5, 12, and this is 5. So at initially, once the spring is point B, what is the length of the hypotenuse? Length of the hypotenuse 13 meters, because right angle triangle formation is there. 12 and 5. So this length is 13 meters. Now this length is 13 meters. So 13 meter length means initially the spring is stretched by a distance of 13 minus 7 means 6 meters. So initially at point B, x, the elongation of the spring is 6 meters. Understood?
Yes, sir.
Now find the normal reaction exerted by the track on the bead when it passes through point A. So if you release at point B, then the spring will try to shorten itself. So once the spring will pass through point A, so at this point, once the particle is crossing, so spring is crossing or the bead is crossing, now spring becomes at this natural length. Why? Because that point
Yes.
is 7 meters. So x is equals to 0. Okay. Now the entire diagram is drawn in a horizontal plane. Why? Because no effect of gravity has to be taken into consideration. Okay. So only thing is that you have to calculate what is the velocity once the particle is reaching at point A. So no effect of gravity means only the potential energy is there and the kinetic energy. What is the potential energy of the spring at point B? Half k into x square, that is 6 square. Okay. And kinetic energy is 0. And once the particle crossing point D, kinetic energy is half m into u square plus spring potential is 0, because x becomes 0. So half of cancels out. So I can calculate u square equals to 36k by m. Okay, 36k by m. Now k is given as 50. So 36 into 50 by m. That is the u square number. Okay, m is the mass of the bead. Okay. Now you are asked to calculate the normal reaction exerted by the track on the bead. That is, if I draw the free body diagram when the particle is passing the point A, so this is the bead location. This is the bead. So at this point, the mv square by r in this direction. Okay. And this is the normal. No effect of gravity. So n is what? N is simply mv square by r or u square by r. So I got u square equal to 36 into 50 by m. n u square means 36 into 50. And what is r? R is 7, r is 5 meter. Okay. That means 36 into 10, which is 360 Newton. So that will be your answer. Okay. 360 Newton is the normal reaction offered by the outer ring on the bead once the bead is coming to point P. Okay. Understood?
Yes.
Okay. That's all for today.